Welcome to College Algebra. Today we're going to talk about quadratic functions. I think this video will be broken down into two parts. We'll start off by just defining them, talking about some of their properties and notation. So, a quadratic function is a second-degree polynomial function. Like I said, with linear functions, we'll go over polynomial functions in more detail in Chapter 5, the next section. But for right now, a polynomial function is just y or f of x equals a polynomial. A quadratic function has this form, ax squared plus bx plus c. You may recognize this notation from when we were talking about quadratic equations. A quadratic equation is this equals 0. We aren't equal 0 here, we're equal y or f of x, because that was our replacement. Graphs of quadratic functions are called parabolas. So, for example, if I looked at if I looked at, say, this function, x minus 2 squared, this squared function shifted 2 units to the right would look like this. Let me see if I can draw that more accurately. Yeah, that's a little bit better. 0, 1, 2, 3, 4, and 4, 4. That's honestly enough for now. Alright, the vertex is the central point here. Sometimes we talk about this line. That line is called the axis of symmetry. It's, as titles go, that's pretty on the nose, because axis of symmetry just means the line around which it is symmetric, and that's what it is. I mean, if you rotate the parabola around this line, it is the same shape. So it's the axis of symmetry, is just the line around which it is symmetric. Domain of every quadratic function is negative infinity to infinity. The range will be more limited than that, just because they always have a lowest or highest point. If it's an upward facing parabola, it has a minimum value, so it would be from whatever this y value is up to infinity. If it's a downward facing parabola, it would be from negative infinity up to whatever this y value is, would be the range. Some forms. This f of x equal ax squared plus bx plus c is called the general form, or sometimes standard form, of a quadratic equation. And then a times x minus h squared plus k, where the vertex of the graph is at hk, is called the vertex form. In fact, the one I drew not too long ago, where I had f of x equal x minus 2 squared, that was actually in vertex form, because remember, if we looked at it, we had our vertex at 2, 0. Well, 2 is here. There's nothing outside because the y-coordinate of the vertex is 0. This is a very useful form to have it in, just because you can just read the vertex off when you have it in that form. It's also useful for some applications. But of course, you're not necessarily going to get it in that form. You might just as soon get it in this form, when it's all multiplied out and combined. But to convert from one to the other, you just complete the square. The a's in both forms, this a and this a, are the same. In fact, you can see that if I multiply this out, this will be x squared minus 4x plus 4. A here is 1, a here is 1. And the sign of a actually determines whether it's an upward or downward facing parabola. This was an upward facing parabola because a was positive. There's actually a neat memory device for knowing that. It's a bit childish, but it's cute. If a is positive, it is an upward facing parabola. If a is negative, it is a downward facing parabola. See? Cute. So let's do an exercise. This is based on problem 29 from our textbook. We have negative x squared minus 2x And we're going to use the graphing tool to graph the function. Well, there's two real methods of doing this. We're going to actually just do completing the square for this attempt, but we'll look at some other methods later. So, if we grab our mark, well, I guess we can actually, well, I guess we got to do some work before we can plug it in. So, we have f of x equal negative x squared minus 2x. Well, we can, to put it in vertex form, we've got to complete the square, so x squared plus 2x. And then, let's see, b is 2, so 1/2 times 2. I am completing the square right now. If you don't remember the steps of it, we first started talking about it in R5, then we did it again in 1-2, and then again in 2-4. But yeah, 1/2 times 2 is 1, then 1 squared is 1. Now, what's going to be a little bit different about this time we applied is that we don't really have another side of the equation to add to, so I'm going to keep it entirely on one side. So we got x squared plus 2x plus 1. Now I also need to subtract it, so I have equality. You know, I haven't changed this side if I've added and subtracted it. But for this to factor, I need only this part to be inside the function. So how do I make that happen? Well, if I remove the parentheses from everything, I would have to multiply the negative through every term. But that's also true if you just want to remove the parentheses from one term. So I still keep this negative out front, have the x squared plus 2x plus 1, but then negative times negative is plus 1. And this will factor to x plus 1 squared. You can either factor it normally, or just note when you're doing completing the square process, what you always get inside your binomial at the end is your variable plus your a, basically, plus whatever you got for your half step, which would be b squared. So whatever you get from your half step. So that's now in vertex form, and we can see what's been done to it. It's had a vertical reflection, which would be a reflection in the x-axis. It's been shifted down, up 1 unit, up 1 unit, and then left 1 unit. So if we start plotting this, I can move this over. Yeah. There is a parabola. So we want to reflect about the x-axis. Then we want to shift up 1. Oh, that's 2. Up 1. And then we want to shift left 1. There we go. Close that. Save. Check answer. And there we go. Let's look at a problem that's a little bit more involved. Let's do this problem based on number 47. If you look at the instruction, we're going to graph the quadratic function by determining whether its graph opens up or down, and by finding the vertex, axis of symmetry, intercepts. Vertex, axis of symmetry, and intercepts. Does the graph of f open up or down? You look at this, it's a, this is negative, so it opens down. Vertex. Alright, we'll learn another method for doing this in the next video, but for right now, let's just complete the square. So if I pull out negative 4 from my two x terms, I'll get negative 4 times x squared minus 1/2 x. Got my plus 4. Then, complete the square. I'd take half of this, 1/2 times negative 1/2. It's negative 1/4. And then square it. So that's 1/16. Then I got to add and subtract it. So negative 4 times x squared minus 1/2 x plus 1/16 minus 1/16. Bring out Negative 4 times negative 1/16. That'll be positive 1/4 plus 4. Inside here, it'll be x minus, what I got from the half step was 1/4, so x minus 1/4 squared. X minus 1/4 squared. 4 is 16/4, so that'll be 17/4. And there we go. I forgot my negative 4, but yeah. Our vertex will be at 1/4, 17/4. The axis of symmetry. We haven't really talked about this yet, but if you draw the function, we've got our 1/4, which should be right here. 17/4 is 4 1/4, so right there. And then going down, I'm not going to draw this to scale, but we'll draw a more exact version here in a second. I just want to talk about the axis of symmetry. The axis of symmetry, remember, is this line. So you can tell what it would be just looking at the graph, but it's always just going to be x equals, because that's the equation of a vertical line, whatever you get from the x-coordinate of the vertex. So this is x equal 1/4. And it is important in this, do not type 1/4. Type an equation. X equals 1/4. Alright, let's find the intercepts. X-intercepts you can find either by setting this equals 0, which if you do that, you divide out everything by 2, get negative 2x squared plus x plus 2 equals 0. And then you probably have to do quadratic formula. But if you've already put your equation in vertex form, it's a little easier if you do it this way. Plus 17/4 equal 0. So then, move over the 17/4. Negative 4x minus 1/4 squared equals negative 17/4. Divided by negative 4. X minus 1/4 squared equals 17/16. Square root both sides. X minus 1/4 equal plus or minus the square root of 17/4. Square root of 16 is 4. Square root of 17 is just square root of 17. Then add the 1/4 over. X equal 1 plus or minus the square root of 17/4 are the x-intercepts. So yeah, it's a little bit easier if you do it in this form, because this one you've got to actually do full quadratic formula, which is doable. It just takes a little bit longer. Negative 1 plus or minus square root 1 minus 4 times negative 2 times 2 over 2 times negative 2, so negative 4. So you'd have to simplify the inside of that. Oh, I don't know. This isn't too bad. We would get negative 1 plus or minus, inside of that, I guess it will just be 17 over negative 4. Now you might ask, but I have positive 1. Well, notice I have negative on the bottom. Divide top and bottom by a negative, it'll change that sign and that sign. So yeah, it is the same. X-intercepts, let's see if it'll take the plus or minus. So you need a fraction. Oh, integer or decimal. Well, I can't do the plus or minus then. So, get my calculator out. So we have 1 plus the square root of 17. Close that, divided by 4. And while I'm here, second entry, get my previous entry, just change that to a minus. So we have 1.28 and negative 0.78. Comma, negative 0.78. Y-intercept, that one's easy, because that one you're setting x to be 0, so you can either plug into the original, which is usually easiest, 0, 4, or I mean you can plug into our vertex form as well. If you plug in there 0, you'll get the same thing. But let's just go ahead and plug in here 0, 4, so this will be 4. And then that graph. Well, let me drag this over. Don't really need this stuff anymore. So we're going to make ourselves a parabola. Going to plot the vertex. Vertex was at 1/4, 17/4. So up, 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 up. There we go. And then we just need another point. We've already found the y-intercept is at 0, 4, so that's convenient. That'll work. Save it, check it, we're done. Oh, we still got to do domain. Domain, super easy. Every domain problem in this section and in 4.1, you can just say it's negative infinity to infinity, because that's the domain of every quadratic and linear function. Range, of course, will vary, because the range of this one goes from negative infinity, goes infinitely down, up to, well, our maximum value here was 17/4, so 17/4, and we do include it. Increasing. So on what set of its domain is it increasing or decreasing? Well, it's increasing, going up as you go left to right, from negative infinity till it reaches, what was it, 1/4? Yeah, 1/4. So, negative infinity, comma, 1/4. I'll get rid of my stuff here. I already put a lot in. And remember, you never have a bracket on an interval of increase or decrease. Decreasing then the other side, 1/4 to infinity. I think that'll finish us for this first part of this section. Next part, we'll look at the vertex formula, and then we'll actually probably slide into 4.4 some, as well as we deal with applications of quadratic functions. I think we're really going to talk about basically 3 sets of problems. We may extend into a 3rd video if the applications take too long, but I think that'll be it. Have a great day. See you guys later.